Namaste students, I am Jagan Dr. H. Sumit Khan from Department of Food and Biotechnology, Faculty of Agriculture and Working Science, Jyoti Vidyapith, Social Chapter. Today I am going to discuss about the topic ultrafiltration. This topic belongs to the downstream processing, BSc Biotech's 6th semester. So, in previous video I discussed about the membrane filtration, and this is the continuous part type of the membrane filtration. What kind of filtration methods can be used? It's the first, second, third. Dialysis are used. So first, now discuss about the ultrafiltration. Ultrafiltration is physically separate solid from the liquid streams based on the principle of the size exclusion. What is the size exclusion? Means larger particles and the smaller particles separated. Ultrafiltration is a membrane filtration process which is similar to the reverse osmosis using hydrostatic pressure to force water through a semi-permeable membrane. The molecules are filtered by hydrostatic pressure to force water through a semi-permeable membrane, and the pore size of the ultrafiltration membrane is usually 103 to 106 Dalton. 103 to 106 Dalton. Ultrafiltration is a pressure-driven barrier. Okay. It is a pressure-driven barrier to suspend solids, bacteria, viruses, toxins, and other pathogens. It is used to produce water with high purity and low salt density. So, if we talk about to remove some microorganisms from the water, then we can use ultrafiltration method, which is very effective because it will separate all the bacteria, all the viruses, all the endotoxins, proteins part. So it is very effective in treatment of the how the suspension are conducted, how they are treated. We are going to discuss all the things in this lecture. The suspended solids and the solids of high molecular weight are retained. The high molecular weight are retained. They will not be allowed to pass through the membrane. They will not be allowed to pass through the membrane. But the water and the low molecular weight solutes will be allowed by the membrane to pass through separately. We know that what are the low molecular materials. We know that only water is a low molecular weight. Ultrafiltration is not fundamentally different from the process. Microfiltration and nanofiltration, except in terms of the size of the molecules. Only it is based on the size. So it is different from another techniques like microfiltration, nanofiltration, osmosis. It is different from these techniques on the basis of the separation on the basis of size. A membrane or more, a semi-permeable membrane is a thin layer of material which is capable of separating substances within driving force. In the ultrafiltration, some molecules which are separated include the bacteria and other microorganisms, some particulate material, some natural organic materials are separated, some endotoxins are separated, some plastic waste are also separated, proteins are separated, silica is separated, silt is separated, smoke, viruses, these are separated. Okay, this separation process is used in industry. Ultrafiltration is used in the industry and research for the production and concentration of the macromolecules of 3 to 106 Dalton solution, especially tissues for the protein suppression. And the flow diameter of ultrafiltration material is about 10 to 1000 armstrong. The particulate must have a size of the 100 to 1000 armstrong to be separated. The pore size of ultrafiltration is mainly responsible for the determining the type and size contaminants. In general, the membrane pores range from the 0.005 to 0.1 micron, and ultrafiltration manufacturers classify each ultrafiltration products as they have specific molecular weight. They have specific molecular weight cutoff. So it must be remembered how the ultrafiltration uh, materials are prepared and are the basic design ultrafiltration product formulation. So the answer is the molecular weight cutoff. Okay. A molecular cutoff is a rough measurement of the sites contaminants which are removed by a given ultrafiltration membrane. How the ultrafiltration perform its separation? The solid suspension solid and the solutes of high molecular weight are retained. They are retained by ultrafiltration membrane, but the water and the low molecular weight solutes will pass through the membrane, which are known as the permeate. The principle of ultrafiltration is that the relationship between the applied pressure on the solution to be separated and the flux through the membrane, most commonly described by the Darcy equation. What is the Darcy equation? According to this Darcy equation, J is equal to TMP divided by micro RT. J is equal to TMP divided by micro RT, where J J is the flux, means the flow rate of the permeable membrane, means the speed of the permeable, and this J will be equal to TMP divided by micro RT. So TMP is the transmembrane pressure. What is TMP? Transmembrane pressure. The pressure difference between the feed and the permeate stream. Micro. What is micro? Micro is the solvent viscosity. How the solvent is viscous. And RT is the total resistance. Means the sum of the membrane and the foreign membrane. So the J will be dependent, the flow of membrane will depend on the pressure and solvent viscosity and its resistance. Three things. How the membranes are composed in the ultrafiltration. The membrane used for the ultrafiltration should have high porosity and should have narrow pore size distribution. Must have narrow pore size distribution. The polymers which are used in the ultrafiltration include the cellulose acetate, cellulose triacetate, polyvinyl alcohol, polysulfone, polyamide, porous carbon of alumina, polysulfone. So these are the materials which can cellulose acetate, cellulose triacetate, polyvinyl alcohol, polysulfone, polyamide, porous carbon of alumina, and polysulfonate. So these are the materials. The factors which affect the density of the membrane. What are the factors? First one is the size of the molecules. The size of the molecule will be larger, it will be separated. Next is shape of the molecule. What is the shape? Shape, longitudinal shape will be not allowed to pass through the membrane. Membrane material is very important. Okay. Presence of other solutes. If there are some other solution in the mixture, in the product, then they will disturb the separation method. It will be very complicated. Membrane configuration is also important. How the membrane is configured into holocarbon, to mixture, okay, and heat formation. What is the configuration? It is very important. And the last one is the falling and the absorption effects. First one is size of the molecule. Second one is the shape of the molecule. Third one is the membrane material. Fourth is the presence of other solutes. Fifth is the membrane configuration. Sixth is the falling and absorption material. So the pore size of the membrane is larger than the reverse osmosis, and the membrane are mostly used for the fractioning processes. The pore size of ultrafiltration membrane range from the 0.001 to 0.2 micron. What is membrane falling? Uh, the major challenge facing the ultrafiltration is the membrane falling. What is the membrane falling? Over the time, the filtration will accumulate in the membrane surface and it will clog the pores. Greatly, it will reduce the membrane effectiveness and efficacy. It reduces the effectiveness of the pressure TMP of the system. Therefore, it will reduce the permeate rate. And the increase in the concentration layer at the membrane will decrease the permeate flux, and due to the increase in the resistance, which reduces the driving force for the solvent. The method have been developed to reduce its effect in the continuation operation. So what is the membrane falling? If some larger particle will start to accumulate on the surface, okay, the larger particle will start to accumulate on the surface of the membrane filter. They will form a cake or gel layer which will not allow some smaller particles to pass through. Okay. It will not allow the smaller particles to pass through the membrane. So it is known as the membrane falling. So there are different types of membrane falling, such as the particulate deposition, scaling, wire falling. Okay. So these are the types of the membrane falling. And what are the different applications of the ultra filtration? They are used in the water treatment. They are used in the biotechnological applications. They are used in the dairy industry. They are used in the animal protect industry. So these are the applications of ultrafiltration. And some another applications are also there of ultrafiltration techniques, such as the filtration of effluent treatment, removal of the pathogens, fruit juice, and so these are also some applications, but we'll discuss in next two videos the membrane type of membrane falling and applications of ultrafiltration. We discussed in videos. So what students have learned from this lesson? In this lesson, students have learned what is the ultrafiltration, general introduction of the ultrafiltration, what particulate material will be separated from the ultrafiltration. Okay. What is the pore size of the ultrafiltration? What is the working of the ultrafiltration? What is the basic principle of the ultrafiltration? And what should be the diameter? What are the polymers which are used in the ultrafiltration methods? Which factors will affect filtration by the ultrafiltration? So students have learned all these things from this lesson. What is the pore size? And what is the membrane falling? So these all the things are explained here, And the questions which can be asked in combination with another include the explain ultrafiltration techniques and their management process, and that's in the principle, and explain types of nominal falling, and explain the material. What are the materials which are used in the ultrafiltration methods, and what are the pore size, what is the working of the ultrafiltration. So these all are the basic idea about the ultrafiltration. I hope students will better understand all these things, and they will answer it quickly. So my lecture is over here. If you have any query, you can ask me. Thank you very much.